Good day everyone! Welcome back to my math tutorials. Today I will be discussing one of the easiest factoring technique, factoring difference of two squares. Recall that in the discussion about special product, the product of the sum and difference of two numbers, a plus b and a minus b, is equal to the difference of two squares. Thus, the product is expressed as a squared minus b squared. Conversely speaking, the factors of the difference of two squares, a squared minus b squared, will always be the sum and difference of two binomials, a plus b and a minus b. Now, let's take a look at these algebraic expressions. M squared minus 49, 4x squared minus 25y raised to 4, and 16a squared b raised to 4 minus 81c raised to 4 d raised to 6. Observe closely. What can you say about each term? Very good. All terms are perfect squares, and each term is connected by a minus sign. Therefore, these algebraic expressions are examples of difference of two squares. Now let's have a discussion on how to factor each binomial. To start with, let's have the steps in factoring difference of two squares. Don't worry, we only have two steps. The first step is to get the principal square root of each term. And the second step is using these principal roots, we need to form two factors, a sum and a difference. Let us start with the first expression, m squared minus 49. Taking the principal square roots of m squared and 49, the answers are m and 7. Forming two factors, sum and difference, we have m plus 7 and m minus 7. Thus, the factored form of m squared minus 49 is m plus 7 times m minus 7. How about the second example? 4x squared minus 25y raised to 4. What do you think is the principal square root of 4x squared? How about the principal square root of 25y squared? Correct. The principal square roots are 2x and 5y squared. Forming two factors, the sum and difference, we have 2x plus 5y squared and 2x minus 5y squared. Therefore, the factored form of 4x squared minus 25y raised to 4 is 2x plus 5y squared times 2x minus 5y squared. Now let's have the third example. 16a squared b raised to 4 minus 81c raised to 4 d raised to 6. What do you think is the principal square root of 16a squared b raised to 4? How about the principal square root of 81c raised to 4 d raised to 6? Yes, the principal square roots are 4ab squared and 9c squared d cubed. Forming two factors, the sum and difference, we have 4ab squared plus 9c squared d cubed and 4ab squared minus 9c squared d cubed. Therefore, the factored form of 16a squared b raised to 4 minus 81c raised to 4 d raised to 6 is 4ab squared plus 9c squared d cubed times 4ab squared minus 9c squared d cubed. Now, let us extend your understanding. Is 8x cubed minus 50x y squared factorable? is the difference of two squares applicable for this binomial? Note that 8x cubed and 50x y squared are not perfect squares. But if we are to observe it closely, then we would say that there is a greatest common factor of 2x. And taking it out will give us 4x squared minus 25y squared as another factor. And this one is already under the difference of two squares. Thus, taking the principal square roots of 4x squared and 25y squared and forming two factors, sum and difference, will give us 2x plus 5y and 2x minus 5y. Therefore, the complete factored form of 8x cubed minus 50x y squared is 2x times 2x plus 5y times 2x minus 5y. Thank you for joining me in today's discussion. See you in my next video.